Although you may not be able to see all forces, you can most definitely experience the effects of forces. They can make objects start moving, move faster, move slower, stop moving, change direction, and change shape. Let me give you an example of push and pull forces. When you ride your bike, your foot pushes against the pedal, which makes the wheels of the bike move. When you drop something, it is pulled to the ground by gravity. Before we move on, let's cover one large misconception. Imagine a stationary box on a table. Are there any forces acting upon the object? It's not like anything is pushing or pulling at it while it's still. If you choose the answer no, you are incorrect. There's much more to forces than you believe. The force that is acting upon the still object is gravitational force. It is known as a non-contact force, including electrical force and magnetic force. It is called gravitational force because it attempts to pull masses together and never pushes them apart. This force of gravity is trying to pull the box towards the center of the Earth. With that being said, the ground is applying an equal force in the opposing direction. This force is called the normal force. The two forces do not change position of the object because they are balanced. The net force acting upon the box is zero. Balanced forces are when two or more opposite forces have effects which cancel each other and don't cause change in an object's motion. The definition of a net force can be defined as a vector sum of all the forces acting upon the object. In order for an object to move, the net force must be greater than zero. Let's say there is a person who is pushing a box with a force of 7 newtons while the box has 2 newtons of force. In order to calculate the net force, we must subtract the smallest force by the greatest force. So, can you recognize if this example of force is unbalanced or balanced? Unbalanced. The person's force was greater than the box and did not cancel out one another. Another example is when a person kicks an object, which is the applied force in this scenario. As the ball moves, it causes displacement, which is the change in original position. When the ball slows down, it will eventually come to a halt. Now, can you make a guess if there was any forces that slow down the ball? It starts with an F and ends with an N, and that will be friction. Friction is a contact force, which is a type of force that is in contact with the object. Not only is there friction on the ground, there's also air resistance. Let's review some basic information as a conclusion. Push and pull forces act in particular directions. Let's double check if you were listening closely to the video. Is there any forces acting on a still object? Yes, gravitational force. One of the 3 main non-contact forces, following electrical force and magnetic force. And then the 7 contact forces are push, pull, normal, applied, frictional, and air resistance. And last of all, although not all forces may be seen, their effects certainly can.